So we're going to find the missing terms of the arithmetic sequence. And on this problem, there's a couple ways to do this. But what I'm going to point out here is the values that we know. This is, we could say that this is a sub 1, and then this blank space in between is a sub 2, which means that this is a sub 3. And we can use our formula to figure out that middle term. And then, actually, we can use our formula to find the common difference, and then we can figure out the rest of the terms here. So once again, a sub 1 is 8, a sub 3 is 52, and a reminder here that that's like a sub n, and consequently that means that n is 3. So we're going to use this first value here, the first formula. It's going to be a sub 3, whoops, and I'm going to write it down. So a sub 3 equals a sub 1 plus n minus 1 times d. So we're going to fill in what we need here. I just did a little bit extra here. We're going to put the 52 in, equals the 8 plus n, 3 minus 1 times d. We're going to solve that equation. So we get 52 equals 8 plus 2d. Subtract 8 from both sides. 12 minus 8 is 44 equals 2d. And finally, divide both sides by 2 gives us a common difference of 22. So once we know that the common difference is 22, then we've already seen a problem like this on problem number 2. We know the common difference. I'm going to write it up here so we can see it. But what we're going to do when we go to the right is that we are going to add the 22. So 8 plus 22 is 30. Check and balance. Does 30 plus 22 equal 52? Yes. 52 plus 22 is 74. And then 74 plus 22 is, not 86, how about 96? Put a comma in there. So when we went to the right, we added those values. So when we go to the left, and change colors here, we're going to subtract 22. And don't hesitate to use your calculator if you need to. It's going to be 8 minus 22. And 8 minus 22 gives us the negative 14. Same idea here. Find the missing terms of the following arithmetic sequence. Well, we know the first term, and we know the last term, and we need to find all those terms in the middle. So let's list what we know. We know that a sub 1 equals negative 12. We know that a sub n, but we actually know what value it is, because negative 12 is the first blank. So here's 1, 2, 3, 4, 5, 6, 7. A sub 7 is 468. And consequently, once again, remember this is a sub n. This means that n equals 7. And we can use this to find the common difference so that we can find our values. We're going to be using that top formula, which will be provided for you. So it's going to be a sub 7 equals a sub 1 plus n minus 1 times d. And we're going to fill in what we know. 468 equals negative 12 plus 7 minus 1 times negative 12. And, sorry, it's not 7 minus 1 times negative 12. We need to figure out what d equals. So we have 468 equals negative 12 plus 6d. 7 minus 1 is 6. We can add 12 to both sides. If we get 480 equals 6d. And then to undo the multiplication, we're going to divide by 6. So we'll get D equals 80. So we know our common difference is 80. And once we know that, in this particular case, since we're going to be completely going to the right to fill these in, we're simply going to take negative 12 plus 80. Gives us 68. And it's going to be 68 plus 80. Gives us 148. 148 plus 80. 228. 228 plus 80 gives us 308. 308 plus 80 gives us 388. And then check it. Remember, there's a check and balance in here. Does 388 plus 80 equal that last number there of 468? When we compare it back here, sure enough it does. So we know that we have the problem correct before we turn in our test. Problem number 6. Find the missing terms in the geometric sequence. Well, like we did on the arithmetic, let's say that 10 is the first number that we know. So let's call that a sub 1. But we've got a blank and another blank. So this 1250 is a sub 4. Because 10 is the first, blank is the second, next blank is the third, 1250 is the fourth. So we know a couple of things here. What we don't know is the common ratio. So we have to find the common ratio. And what we're going to do for that is we're going to use that first formula, and I'm going to write down again what we know. We know that a sub 1 equals 10. A sub 4 equals 1250, and this is really a sub n, so that also tells us that n equals 4. Using that first formula, a sub n equals a sub 1 times r to the n minus 1, and let's fill in that formula. Well, a sub n, 1250, equals 10 times r, we don't know the r, it's 4 minus 1. And remember when you solve this, you need to isolate the r first. We're going to divide both sides by 10. And when we do, get 125. R to the 4 minus 1 is r cubed. And if you think about your quick recalls here, I bet you can do this. Because what number times itself again gives us 125? Well, it's r equals 5. I left a little bit of space because some of you need to see a little bit of different work there, but if you remember your quick recall facts, that's that. The way to undo r cubed here is to take the cube root of 125. And the place that you do that on the calculator is you go to math and number 4 and then type in 125. That's also a place where you can get the 5. But now that we know that our common ratio is 4, common ratio is 5, and we can fill this in. And just like a problem that we did earlier on this, when we go to the right, we're multiplying. So we're going to take 10 times 5 is 50. 50 times 5 is 250. Check and balance. 250 times 5. 1250. We're good so far. 1250 times 5 gives us 6,250. So we multiplied when we went to the right. We need to divide when we go to the left. So we're going to take 50 divided by 5, and again, there's a check and balance again. 50 divided by 5 gives us the 10. And then that is what we see here. That's our A1 that we labeled at least. And then we're going to finish by taking 10 divided by 5. And we get 2.